So here is the link to GeoGebra Classic. I hope that anybody can follow it, and your browser, whatever you are using, is good enough to have and run GeoGebra. I mean, GeoGebra also has apps, at least for Android. I have it on my devices. It's not super convenient to use it on a tablet or on a phone, as with many other things, but still, it's quite possible. Anyway, this is how GeoGebra looks like. You can see the coordinate axis. So there is this canvas where we can draw things and do certain things with certain geometric objects. There is the toolbar, which will be quite important. There is this input place, and there will be also some descriptions of the object that we create here. And I understand that screens and apps look different depending on what device you have. So don't panic if the GeoGebra doesn't look exactly like this on your computer, depending on your screen aspect ratio and other things. It may look differently, but anyway, it should have some of the features that we are discussing. There are quite a few tutorials on GeoGebra online. I mean, you can search for them. Of course, I will give enough information for you to use GeoGebra in this course. But anyway, if you are lost, ask me or ask Google. It's a really powerful software. I think I'm not using maybe 1% of it, and even less will be in this course. But still, here is what we will be doing. So one thing that I will do, you don't have to do it, but we don't need the coordinate axis. So here I'm right-clicking on the mouse and telling not to show the axis, and also right-clicking and telling not to show the grid. If you want, you can do that. You don't have to. And we will be working with geometric objects in GeoGebra. And there are several objects. There is a steep learning curve, but maybe the most important one is the point. And to place a point, well, you have to go into this mode where you're placing points by clicking this menu item. And now you can start placing points. Every click is a new point, and it gives you the coordinate. Okay, so far it's just the drawing thing. And of course, you can place points in various other softwares. The good thing about GeoGebra is that it is interactive. And now we will start the interaction. We will be moving points, not very exciting interaction, but we will have it more. So in order to move points, you have to go into moving mode. And the moving mode turns with this one, the selection tool, or whatever you want to call it. The shortcut, the keyboard shortcut for that is escape. So if you click on this arrow or hit escape, then yes, you can get to this mode where you can grab a point and start moving it. And you can see, well, this point A, as it is moved, its description changes. It's not maybe super important, but that's how it is. So grab a point and you move it, move another point, and so on. Okay, so far also not too exciting, but GeoGebra has many other things. So I will clear the canvas now. I will select all the points by just doing Control-A, but you can also do it point by point and deleting them. So here you also have other things. For instance, you have polygons. So you may define, just clicking the polygon. There you go. That's one polygon. Here is another polygon. Oh, that would be a triangle. Okay. And as far as the visibility graphs go, we can create a scene with the obstacles by defining 2 points, S and T. Of course, now they are called something different. But what we can do is we can rename these points. Again, you have to go into selection mode, I guess. Right-click on a point, and then you can rename it. And let me call this point S. Here we go. Now it's called S. And let me do the same with this point. Let me rename it to T. Okay, so we have 2 points, S and T, and we can say that these 2 polygons are obstacles. And there's lots and lots of stuff that you can do. You can customize your points and so on and so forth. I mean, you can say that I don't want to show the label, and oops, the label is not seen. You can say I don't want to show the point, show object, the object is not seen. There are many, many more object properties that you can change in settings. You can change the color, the style. So now this point is red, and so on and so forth. Lots and lots of things. Again, I'm not touching even a fraction of what GeoGebra can do. So what's next? We can draw the visibility graph, and let's do that. One quick note is that some edges of the visibility graph are already there. Reminder, the visibility graph is the graph whose vertices are vertices of the obstacles. So we have the vertices. Well, not all of them are seen. Maybe we should get back this point if we can do that. No, I don't think that's possible, but I guess it's possible here from the tools. Yes, so here this point is not highlighted. Yeah, there it is back. Well, we didn't really have to have it, but just for completeness, we could get it back and also show the label of this point. Anyway, so returning to the visibility graph, recall the vertices of the visibility graph are the vertices of the obstacles. So all these points A, B, C, D, E, F, G, H, and points S and T. And the edges of the visibility graph connect visible points, or pairs of points that are mutually visible. And again, just to remind you, some of the edges already here. So like endpoints of the same edge, they see each other, well, and they are here, we don't have to draw them. What we do want to draw are the edges of the visibility graph between non-adjacent obstacles. And how are we going to do it? Well, we're going to draw segments. In order to draw segments, we will go into this toolbar in GeoGebra and choose the that's point. From here, choose the segment. Okay, so in this toolbar, you have quite a few things. You can do lines, you can do rays, and other things, but this time we need segments. And well, it suggests to select 2 points or positions, and you can draw a segment. So you can draw an arbitrary segment, like from here to here, between 2 points that didn't exist earlier. But I'm doing Control-Z and removing what I just drawn. You can also do a segment between 2 points that were already here earlier, like between B and F. There you go, segment. Maybe I talk more than what it is. You connect points by segments. And of course, the good thing in GeoGebra is that it's now it's glued. Again, I don't think it's unique to GeoGebra. Even in PowerPoint, you can connect 2 points by a line segment, and as you move the point, the line segment, the length of it changes. So yes, no rocket science here. We connect, connect all pairs of visible vertices. So here is the visibility, again. Here is the visibility graph. Just clicking 1 point, another point, 1 point, another point, 1 point, another point. The good thing about GeoGebra is that you can quickly check whether this point sees this. Yes, no intersections. I don't know, does this point B see point H? No, I guess there is an intersection here, so it doesn't see it, so that will not be an edge in the visibility graph. Let's see, we still have to connect the point S to all the points, all the vertices it sees. Does S see B? Yeah, looks like it does. Let's put the edge. And now, of course, you can scroll the mouse wheel and yes, get the zoom. And yeah, you can see that indeed point S sees point B. There are also other things like you can move, if you're in this mode, I guess with the mouse wheel, you can move the canvas. If you don't have the mouse wheel, you can use this one tool. You can zoom in, zoom out, lots and lots of things to do. But anyway, those are pretty standard. And even the thing that we are doing now, adding the segments between points, I think these are quite intuitive. I see there is one edge which we haven't added yet. Do you see it? If yes, you may put it in chat. If not, I will add it in a second. Yes, very good. Yes, somebody got it. C to H. Yes. C to H. There it is. Anything else? I don't see any missing, but maybe I'm being blind. Well, I think we have our visibility graph. Of course, this is since we added the edges kind of by hand, well, the visibility graph may change as we move the vertices. And in particular, it may be so that some of the segments that we added are no longer there. So like if we take this point A and move it over here, well, this segment from S to B is not a visibility edge, it intersects an obstacle. And well, our simplistic simplistic canvas doesn't show that. I mean, it's still a visibility edge. There could also, some visibility edges may appear as we move the vertices. Like what was it? Yes, so between B and H, we didn't have a visibility edge, but if we move this G, then of course, B starts seeing H. So yes, our app is not very advanced. In GeoGebra, you may actually have some conditional statements for existence of certain features, like if segment intersects another segment or intersects a polygon, that segment is not shown, and so on and so forth. So you may, in principle, have the visibility graph, which is fully dynamic and perfectly changes as you move your vertices, but we are not doing that. So we are still using our eyes to do some of the things, to understand what is seen and what's not. But anyway, hopefully this was simple enough. Again, I guess it's more intuitive than maybe I've spent too much time discussing it. So yes, let's now look at some paths from S to T. There is a polyline function somewhere here. It was right here. It is polyline, and yes, we select vertices. And I hope we don't have to do a closed polyline. And let's go from S to T. So S, B, F, T. I double click, and yes, I'm trying to see where my polyline is. So we are doing a polyline in here, and as this suggestion says, you select vertices and then you select the first vertex again. So I was double clicking on the last vertex, as I would do, let's say, in PowerPoint, but actually you have to do 1, 2, 3, 4, and then to say that I'm done, I should click the first vertex. And now here I have my polyline. So you can see here in the list of objects that I have created the polyline, and in fact I want to make it different. So now it's all black and it's not seen under the black visibility edges. So let me change the color of it to blue, and maybe let me make it thicker like this. Yes, so I have my polyline. So that's a path from S to T, the blue thing. And in fact, this number right here shows the length of the path. Okay. So that's one path from S to T. Let's click in another polyline, again going from S to T like this. So I'm getting to T and clicking the last point. So here I have another polyline. Well, let me make it red, just to distinguish it from the other one. And maybe I would also want to make it a bit thicker, just like the previous one. So there is style. You can change line thickness and do many other things. And well, now you see that the red path is slightly longer than the blue path, right? But you see that it's only slightly longer. And if we start moving the point T, the lengths of the two paths change. And well, now the blue path is longer. So somewhere here, there is a bisector. Bisector meaning the point to which the length of the shortest path from S to T is the same for two paths. So there are two paths delivering the shortest path. I don't think we will be able to do it precisely because there are some square roots involved, but you can approximately see where the bisector is. I mean, it's not here, it's not here. You see how the lengths of the path change somewhere around here. So the lengths of the paths are approximately the same. Okay, so that's a quick introduction to GeoGebra and the end of this video.